Welcome, Hornets, and thank you for joining me today. Today we are looking at part 2 of assignment 7, where we are working with the process for definite integration, completing the square, and u substitution with our trigonometric inverse functions. So we're going to be starting at number 21 in part 2, and 21 is a definite integral, and we are looking at the integration from 0 to 1/6, and I have 3 over the square root of 1 minus 9x squared dx. Now, our first step is to recognize that this is a squared minus u squared, which means that my a is going to be 1, my u is going to be 3x, and du is 3dx. Now, I will be very honest with you. You do want to make sure you find your du so that you can see if you have the correct coefficient in front of the dx. If not, you have to put it in. Sometimes people will factor out that coefficient in front of the dx without realizing that it's part of the du. Okay? So once I have that, I'm going to go ahead and I'm just going to substitute everything, 0 to 1/6, and I end up having my du, and I currently have the square root of 1 minus u squared here. So we see this as our pattern. This is then the arc sine, and I have of 3x, and it's from 0 to pi over 6. So I'm going to start by putting in 1/6, my bad, 1/6. And I'm going to put in that 1/6, and you'll notice that I get the arc sine of 1/2 minus, using the fundamental theorem of calculus, the arc sine of 0. Now we know that the arc sine of 0 is 0, and we know that the arc sine of 1/2 is simply when is the sine equal to 1/2 in the first quadrant. Remember, arc sine is only in the first and negative first quadrant, and we are not looking at a negative, so our answer is in the first quadrant. I then think to myself, when is sine 1/2? And I end up with pi over 6. Pi over 6 minus 0 gives me pi over 6, and that's the answer we're looking for. We then move to number 23. So please continue to follow along with me as we take a look at number 23. This is the integration from 0 to root 3 over 2, and I have 1 over and 1 plus 4x squared dx. Now in this, please be aware it's pretty clear that we are looking at the pattern a squared plus u squared. We know that our u is going to be 2x. We know that du is 2dx. And I also recognize that I do not have a 2 in the numerator. Since that's the case, I'm going to want to make sure that I plug in what I have. So here we go. I have the integration from 0 to root 3 over 2. I have a du with a 1/2 on top. And I'm looking at let's make sure I can put this in, 1 plus u squared. Well, with that, I know I'm working with my arctan, so I have 1 divided by 1 multiplied by that 1/2, and I have arctangent, and in this arctangent, I am looking at 2x over 1, and I'm going to simplify this so that I have 1/2 arctangent of 2x from 0 to root 3 over 2. We're going to start with the root 3 over 2, giving me 1/2 arctangent of root 3 minus 1/2 the arctangent of 0. And we know that the arctangent of 0 is 0. And we're now asking, when do I get a root 3? That is a pi over 3. And I'm left with pi over 6 as my answer for number 23. Are there questions? I'm sorry, as I flash back to school, I keep thinking I'm in class. Let's go to number 25, please. Here we go. Number 25, we are specifically looking at the integration from 3 to 6, and I have 1 over 25 plus x minus 3, the quantity squared, dx. As we saw before, we're looking at our pattern, a squared plus u squared. We are saying that u is x minus 3, and we are saying that du is dx. That being the case, I know that I'm looking at 3 to 6, the integration. I have a dx in top, and I have 5 squared plus u squared. Now we know our pattern for this is 1 over 5 arc tangent. We're going to have our x minus 3 divided by 5, and we're going from 3 to 6. We're going to start with the 6. We plug it in. We get 1/5 the arc tangent of 3/5 minus 1/5 the arc tangent of 0. And we know that the arc tangent of 0 is 0. So I'm left with 1/5 the arc tangent of 3/5. Now 3/5 is a non-standard, one of our non-standard values. And so let's just make sure that, the only option I have at this point is to plug it into the calculator to see what I get. So I'm just going to go ahead and do it. 1 divided by 5, arc tangent, 3 divided by 5, enter, and I'm getting approximately 0.10808. And it's going to be one of those two. Let's go ahead and go to number 27. Number 27 is giving me the integration from 0 to the natural log of 5, and I have e to the x divided by 1 plus e to the 2x dx. Now I am going to look at this and say, well, if I have u equaling e to the x power, then the pattern that I have is 1 squared plus e to the x, the quantity squared, which is a squared plus u squared. That's the arc tangent, and therefore, if I have that, I know my du is e to the x dx. And I'm just going to go ahead now and go directly to my answer. 1 over a arc tangent of u divided by a, and we're going from 0 to natural log of 5. We're going to put in 1. This is leaving me with the arc tangent, and I have e to the x from 0 to the natural log of 5. Using the fundamental theorem of calculus, I have the arc tangent of e to the natural log of 5, and that's the arc tan of 5, because the natural log and e are inverses, minus the arc tangent of 1, e to the 0 power. Now we know that the arc tangent of 1 is pi over 4. So I'm looking at the arc tangent of 5 minus pi over 4 as my answer. Now, if I want to find this as a decimal, I will have to plug it into the calculator as second function tangent 5 close parentheses, and then subtract pi divided by 4. You should end up getting approximately 0.5880, and that's my answer for number 27. Let's go ahead and continue to number 29, please. Number 29 is giving me the integration from pi over 2 to pi. And the function is the sine x 1 plus cosine squared x dx. Notice that I'm looking at a equaling 1. U is the cosine of x. Du is going to be negative and then the sine x dx. The pattern that I'm working with is a squared plus u squared, and this is 1 over a arc tangent of u divided by a, and we're going from pi over 2 to pi. So we're now going to plug in our a value, which is a 1. Notice that's going to just give me 1 arc cotangent of cosine of x divided by 1. So this is the arc tangent, and I'm putting in the cosine of pi minus the arc tangent. Let's make sure I have my correct negative that should be in front. After all, I did have that du, and that's going to become a plus arc tangent for the cosine of pi over 2. Now, we know that the cosine of pi is -1. We know that arctangent is an even function. And so we are looking at that negative coming out. Let's just make sure. And let's now go plus. And I have the arctangent of 0. Now we know that the arctangent of 0 is 0. And I'm now going to have to find the arctangent of -1. Now let's think about this. It's got to be in the opposite of the first quadrant because the arctangent is in the first and opposite of the first quadrant. We know that tangent is +1 in the first quadrant at pi over 4, which means that this is negative pi over 4, or we are looking at positive 5 pi over 4. So we have 7 pi over 4, excuse me. So I have the choice. I am looking at the 7 pi over 4, or I am looking at negative of negative pi over 4. Now you'll notice this is now my counterclockwise rotation, and this is pi over 4, and that is what I get here. So pi over 4 is my answer to number 29. This now brings me to number 31, the last of this group of our definite integrals using our inverse functions, 0 to 1 over root 2. And we are working with our arc sine, and we have arc sine of x over the square root of 1 minus x squared dx. Alrighty, so let's see. This time I'm going to let u equal the arc sine of x, because I know that the du is going to be the dx over the square root of 1 minus x squared. And you can clearly see that that's what we're working with. So I have the integration of u and I have du, and this is going to give me 1/2 u squared, and I'm going from 0 to 1 over root 2. Plugging in the 1 over root 2, I'm going to have 1 over root 2 squared is 1 over 2 for 1/4 minus 0, and my answer is 1/4. And that is my answer to number, hang on a minute, I got a problem. I have to back substitute, everybody. I just noticed. Look at what I didn't do. 1/2, because I did not change my endpoints, I have to back substitute. And that means that I have the arc sine of x squared from 0 to 1 over root 2. And this is now giving me the arc sine of 1 over root 2. Now, the arc sine of 1 over root 2 is pi over 4. So I have 1/2 pi over 4, the quantity squared. And that's what I'm going to have to work with. Let's see. This is giving me pi squared over 16 times 2 is 32. And that's what I'm going to plug into my calculator to find my decimal. pi squared divided by 32. And I end up getting an answer that is approximately 0.3084. And there you go. Those are my answers for part two, finding the definite integrals. We're now going to go ahead and go to the next part. This is completing the square. We're looking at numbers 33 through 41 odds only. Then we'll tackle 43, 45, 61, and 63 as we are able. So here we go. Number 33 is giving us the integration from 0 to 2, and I am attempting to complete the square, and I have x squared minus 2x plus 2. Now, I don't want you to try to overthink these. Simply get the pieces that are quadratic and linear and kind of combine them. Now, whatever you add here, you have to subtract here. So if I'm looking at this, x squared minus 2x, completing the square, is plus 1, which means that I have a 2 minus 1. Now, some people are going to want to look at this in a slightly different way. I can break up that plus 2, and I can now make it x squared minus 2x plus 1 plus the remaining 1. It's the same idea. Either way, you should end up working with the integration from 0 to 2. We have our dx on top, and we are looking at x minus 1, the quantity squared, and I have a plus 1 squared. Now, this is an arctangent being a u squared plus a squared, where our u is going to be x minus 1, our a is equal to 1, our du is equal to dx. Here we go. We're now going to put it together into the arctangent. Arctan x minus 1 from 0 to 2. This is going to give me the arctangent of 1 minus the arctangent of negative 1. Now, we already saw in the previous problem that the arctangent of 1 is going to be pi over 4 minus, now we're looking at a negative 1, which is negative pi over 4. I add them together, and my answer is pi over 2. And that's the answer to number 33. Let's go ahead and take a look at number 35 next. Once again, just completing the square. 35 is saying find the integration, and it is an indefinite one this time, so we will be looking at not finding a value, but actively just replacing pieces and finding it with plus c. So x squared plus 6x plus 13. And once again, you've got a choice. Think about it as x squared plus 6x plus 9, leaving the remaining 4 to its side, or take the x squared plus 6x, you have then plus 13, and you're going to want to add 9 and subtract 9. This will give you x plus 3, the quantity squared, plus, and we're now looking at 2 squared. Once again, as I look at this, I notice that this is not going to help me. Notice how I have a 2x on top? This is fine and dandy, but if you look at what I did, my u is going to be the x plus 3 here, which means that du is equal to dx. But I have a 2x dx, and you'll notice right there, it has a plus 6. So I'm going to have to restart this one. Now remember that if you end up doing something wrong as you're going through, I want you to keep going and just try it again. So I'm going to add 6. But if I add 6 in the numerator, I have to make sure that I subtract 6, and therein lies the trick. I'm going to have to break this up into 2 now. I have the integration of the 2x plus 6 dx, and there went my lights. And I have my x squared plus 6x plus 13, If I let u equal x squared plus 6x plus 13, then my du is going to be a 2x plus 6 dx, and that's what I have in the numerator. We then have a second piece, and that second piece, 6 dx, integration, and now I'm completing the square. X plus 3, the quantity squared, and I then have plus 2 squared. Now, this is going to allow me to bring that 6 out, work with this as if it is a normal arc tangent, and try not to let myself get too frustrated. So as I'm looking at this, I have 1 over u du, and I'm subtracting 6 integration 1 over, let's put du here, and I have a u squared plus 2 squared. This is giving me the natural log, and I'm going to put in the x squared plus 6x plus 13. And then I'm going to have my minus 6 divided by 2, arc tangent, and I have the x plus 3 divided by 2 plus c. Last thing I'm going to do is rewrite this so that I can clearly see my answer in its simplified form. Don't let yourself get frustrated. Just do what you got to do, and you're going to be okay. There's number 35. Alrighty, this is going to bring us to our next problem, number 37. So hopefully everybody is following along with me. Number 37. Number 37 is giving us the integration, and we have 1 over. Now I have the square root of negative x squared minus 4x dx. Now you'll notice I can factor out a negative out of this so that I can have negative x squared plus 4x, which means that I'm going to be adding 4 here. But notice the negative outside. That negative outside means that I actually subtracted 4, and I want to make sure that I add 4. You'll notice I now can look at what I've got. The integration, I have my dx up top, I have 2 squared, and it's the square root of 2 squared minus x plus 2, the quantity squared. And you'll notice that this is an arc sine problem. And once again, it is an indefinite integral. So if I let u equal x plus 2, a is going to equal the 2. The pattern is a squared minus u squared, and my du is dx. So I can directly substitute my various pieces so that I can simplify it. I'm going to have my du here, 2 squared minus u squared to the square root, and this is the arc sine of u divided by 2. We're going to back substitute our u. That means we put the x plus 2 where the u is, and don't forget to add c. That's my answer. That's what we're looking for. That's what we're trying to get. Alrighty, we have only 2 more left from this portion. Let's go ahead and try to finish this in the time that we have. So number 39 gives us the integration from 2 to 3. I have 2x minus 3. I have the square root of 4x minus x squared, and I have a dx. Now, just as we saw before, this is a little bit problematic. After all, look at what we've got going on here. I'm currently looking at a negative x squared 4x. If I add 4 here, that's going to have to become a minus. So let's factor out that negative instead. So I'm going to look at this and I'm going to say negative of x squared minus 4x, allowing me to add 4, which is really minus 4, which means that I am adding 4 there. I can see I have a squared minus u squared, but I also see that I have a 2x squared minus a 4x. And that right there is the first step. So you can see that this piece right here is actually going to be in the second part. So let's see what we can do. If I were to take my derivative and I let u equal the 4x minus x squared, then my du is going to be 4 minus 2x, or negative du equaling 2x minus 4 dx. Now that means I have to subtract 1 to get that minus 4, but I'm also going to add 1. And this now gives me the two problems that I'm looking at. 2 to 3 of 2x minus 4 for the square root of 4x minus x squared dx. And then I have a plus, and I'm looking at the integration, and I have dx, and I have the square root of 4x minus x squared. All right, so here we go. In this problem, we're using our u substitution. So we know that we have the negative 2 to 3. I have my du on top, and I have my u to the 1/2 on the bottom. This one, we're going to construct and rewrite it so that it looks like what we had already created with completing the square, which is 2x, x minus 2, the quantity squared. Here are the two pieces. This is the integration from 2 to 3, u to the minus 1/2 power du, plus, and then I am going to have the du, and I have the square root of 2 squared minus u squared. Once again, this is an arc sine, so let's go ahead and begin. I'm going to have negative 2 times the integration of my u, which is 4x minus x squared, and it's to the square root power. That's the 1/2 power. And we are looking at from 2 to 3, plus we have the arc sine of u over 2, and here the u turned out to be x minus 2. Oops, x minus 2, and this is still from 2 to 3. So this is what we're working with. We're going to start with the 3, and I'm looking at negative 2 times the square root of 12 minus 9. This is giving me negative 2 times the square root of 3 minus, now I'm going to do this again, 2 square root 8 minus 4 minus, notice the double negative from the subtraction, so we now have a plus, 2 root 4, which is 2 times 2. Then I'm going to go to this next piece, plus. We plug in the 3, and we have the arc sine of 1/2. And we already know that the arc sine of 1/2 from a previous question is pi over 6. And this is giving me the arc sine of 0, which is 0 pi. I'm now going to add this up, and I am looking at negative 2 root 3 plus 4 plus pi over 6. And I'm going to find this as my decimal. So here we go, just plugging it into the calculator. Negative 2 square root of 3. I am then adding 4, and then I am adding pi divided by 6. The answer that I end up getting is 1.05949, and then a quick check of my answer will show that I am indeed doing it correctly. Okay, this is going to, notice that's a pretty long problem. It's important to recognize that at this point we are looking at fairly large problems, and that's why I need you to pick and choose what you're working with. You know, if you want to do them all, that's fine, but as you can already see by the videos, these tend to be lengthy, and they can go quite a bit. So our last one, number 41, we're now looking at the integration. This is an indefinite integral, and we have x to the 4th plus 2x squared plus 2, x to the 4th plus the 2x squared. This is going to give me plus, and we're looking at just 1, and then I have an additional 1 sitting out there. Alrighty, that means that I have x squared plus 1, the quantity squared, plus 1 squared. This is an arc tangent. If I so choose to use a u sub, let's just make sure we see it. If u equals x squared plus 1, then du is going to be 2x dx, and that means I'm going to have a 1/2 du equaling the x dx. I can then substitute this so that I have my 1/2 du, and then I have u squared plus 1 squared. Once again, this is the arctan, so I have 1/2 arc tangent of x squared plus 1 plus c. And that is my answer for number 41. And that looks good. Alrighty, so that was part 2 of the assignment number 7. I will do the last 4 problems in part 3. Hornets, thank you very much for putting up with this. I hope this has helped. If not, please make sure you put the comments as to why. If it is, please make sure you click like. Thank you very much. Be well, take care, and be safe. And part 3 will be next. Bye-bye now.